Mr. the Committee Chairman, Mr. Gentleman of the Board, Ms. Supervising Professor, at the outset, I would like to express my sincere gratitude and appreciation to evaluate this humble work, which is entitled Home Automation System Controlled by Cell Phone using DTMF technique. This project is accomplished by my friend Zakaria Al-Muqaddam and me, of course, Mamadi Mohamed Amine, supervised by Madam Gmouh Samia, in order to get the master degree in electronic embedded systems. It has two different parts, theoretical and practical. Each part is also composed of two subparts. Let's go into it. Today, technology has become an integrated part of people's lives. It has and it continues to influence many aspects of daily life. Many devices such as mobile phones and computers have made many people relying on the technology to communicate with their friends. The smartphones have allowed people to connect to the internet without a computer, while still offering the same functionality but through different ways. Home automation, called also smart home, is a home-used and automation system to control lighting, climate, entertainment systems, and appliances. Home automation can detect and identify the persons, automatically adjust the lighting to predefined taste, open doors automatically, play a music, water the flower in the morning, switch on the security lights at night and switch them off in the morning, heat water for bath and tea. That makes it possible to link lighting, entertainment, environment, security, telecommunication, heating and air conditioning into one central controlled system. There are three basic types of home automation control systems, which are: first, individual control systems. In this one, we'll find each device, like the heater or the air conditioner, have an independent control dedicated to it. Second, distributed control systems. By this one, we can control several similar devices, for example, the thermostat of several air conditioners. The third one is central control system, which is the most important one. These are computerized systems programmed to handle all functions of multiple utilities. Dual-tone multi-frequency is a method of sending and receiving control information over communication channels. Each digit on the keypad is encoded as a DTMF tone, then it transmitted over an interface and decoded at the receiving end. A keypad is usually used to generate the required DTMF tone. Each key is associated with a row and a column of frequencies. When a key is pressed, the encoding circuitry mixes these two frequencies together and transmits the result. Then the receiver decodes the tone back into its two respective frequencies, and then the processing circuit will act accordingly. Now let's move to the DTMF standards. The International Telecommunication Union standards appear as Recommendation Q23 and a Q24 in Section 4.3 of the Consultative Committee of International Telephony and Telegraphy on the Red Book, Volume 5. Other standards saying that two tones are used to generate DTMF digit. One tone is chosen out of 4 row tones and the other is chosen out of 4 column tones. These standards is available from the Institute of Electrical and Electronics Engineers as NC or I3E standards. DTMF encoding. DTMF signaling is commonly used in telephone equipment. A DTMF signal is a combination of two pure sinusoidal waves, each with different frequencies. According to the International Telecommunication Union recommendation, there are 8 frequencies involved in DTMF signaling. These frequencies are regrouped as low and high frequencies. The figure below mentions the combination of two sinusoidal waves. DTMF town generator. The DTMF code is based on two second-order programmable digital sinusoidal oscillators, one for the row and the other for the column tone. To encode each digit, the two oscillators needs to be loaded with the appreciate coefficient and initial condition before initiate the oscillation. The tone duration specified by International Telecommunication Union is 10 digits per second are the maximum data rate for touchdown signal. For Time's law, a duration is 100 milliseconds. For the actual tone is at least 40 milliseconds and no longer than 55 milliseconds. The minimum pause duration is 40 milliseconds. Dual tone multi-frequency decoding. Decoding a DTMF signal means to extract the two tones in the signal and determine the intended DTMF digit from their values. The principal function of the detection is to determine whether a receiver signal within the DTMF frequency band is a true DTMF signal or just a noise or speech. Now, let's move to the DTMF detection methods. Basically, there are two methods. The first one is zero crossings count method. Tone detection is often done in analog circuits by detecting and counting zero crossing of the input signal. This technique determines the two frequencies that make up the DTMF tone. The second one is Gorzel algorithm method. This technique is used in digital circuits tone detection by transforming the input time domain signal into its frequency domain equivalent. The correct detection of a valid DTMF digit must ensure that there is a minimum energy value at both of the required frequencies. This method is the basis of the new DTMF detector. It's a very effective and fast way to extract spectral information from an input signal. Here we can explain how the system works in few steps. Firstly, when user calls the system by a specific number, the on-off hawk module detects the phone ringtone and activate automatically the off-hawk mode. The MP3 player module sends a vocal message corresponding to this step that's stored before in the SD card. Secondly, user needs to enter correct password to manage the system. If the password incorrect, it would activate on-hawk mode. Thirdly, if the password is correct, the system would send a new vocal message explaining the method to drive the system. Next, user can control any appliances connected with the system by press at his phone keypad and by following the instructions sent in by the system. Then, if the user did nothing in 1 minute, the system will automatically activate on-hawk mode. Finally, if user chooses to turn off or to turn on any home appliance, the relay module would achieve his order and reply with a stayed vocal message. We can say that the system composed of two sections. Remote section, which is the transmitting or the wirelessly remote controlling section that generates the DTMF signals. Here, we have used the mobile phone for this purpose. Local section, which is installed with the house appliances that are connected with the system to control them. The block diagram of the project is showing the relationship between different components. Now, we're gonna move to system components. Our project has three basic sections, which are DTMF decoder, microcontroller, and relays. It has also some specific parts like on-off hawk module and ERP-MP3 player module. We are focusing on the specific elements that are more difficult to find data about. The first component is the MT8870 DTMF decoder. Let's briefly explain how it works. We can hear sound tones while pressing on the phone keypad. These unit tones called DTMF. It stands for dual tone multi-frequency. After all, sound are just a vibration of air molecules. The humans can understand this vibration, but machines can't. In order to convert these audio signals in dimension understandable form, we have to decode these signals. So we are going to use this DTMF decoder model to decode these audio signals. There are a lot of DTMF decoders, but we prefer using this MT8870 decoder because this one comes with a female aux cable connector and with the main header pins and also with a few LEDs. This module has VCC and ground pins, which has to be connected to the power source. And it has also 4 output pins named Q1, Q2, Q3 and Q4. Its block and circuit diagram are shown below. The second component is the on-off hawk module. The main function of this component is to activate off-hawk mode when the cell phone ringing, or on-hawk mode if the microcontroller decided to, by making a quick short circuit between the microphone wire and the ground. The UART MP3 player module. By this module, we can plug the micro SD card that contain the audio files, while the MCU can control the MP3 playback state by sending commands to the module via UART port. The SD card. In our project, we have used the SD card to store vocal messages respectively with different names so the system could reply to users with the appropriate vocals. The next table showing vocal messages list, which is saved in the SD card memory respectively. The relay module has an electrical switches. Its block and circuit diagram are shown below. Control unit. In our project, we have used the PIC16F877A, manufactured by Microchip Technology. We have programmed the PIC microcontroller by using the popular C language known as Micro C, developed by Microelectronica. The control of home appliances is by relay module that is connected to port D on the PIC microcontroller, and this loss is operated from 8 MHz internal resonator. And the next figure represents the control unit circuit diagram. Project program. As we mentioned before that we used Micro C compiler to write the PIC-C code to program the microcontroller, which was built into an hexadecimal code to be programmed into the PIC16F877A microcontroller. And the next figure shows the system flowchart. Now, we are going to move to the simulation and implementation chapter. We have used Proteus software to testify and build the PCB design. Also, we have simulated the system operation, and here are some parts of the simulation procedure. The simulation procedure composed of 2 subparts. The first part is to simulate the on-off hawk and the UART modules with the microcontroller. In this section, we will make sure that the on-off hawk circuit is automatically picking up to incoming calls and make the PIC sending orders to UART module to reply with the appropriate vocal message from the SD card. Firstly, we upload the wave audio file, which represents the phone ringtone, on the audio generator with an amplitude equal to 4 volts. Then we upload the code file into the PIC with an hex extension. The system is in standby mode. When we press the push button, so the audio sound enter, that means an incoming call is ringing. The system will automatically pick up by making a closed circuit connecting the output to the ground. The LED D1 is an indication of that. The system will play a greeting vocal message from the SD card. The LED D3 also indicates that the relay 1 is in the second position, which means the system is accepting the inputs made by the user. This last go directly to the DTMF decoder in order to decode the key pressing tones into 4 binary code. The virtual terminal is an addition part to show the status of the code running and the orders that made by the PIC to UART module in order to play the appropriate soundtrack. The LED D1 will run for a while, again as an indication of the closed circuit. The PIC will give the order to play the gratitude soundtrack as the terminal shows, then hang up the call. The relay 1 will turn into the first position, making the system in standby mode. The second part of the simulation is to simulate the relay module with the microcontroller. In this section, we will make a test to control 4 relays which represent the electronic devices in our system by the microcontroller. As we mentioned before that the DTMF receiver decodes the key pressing tones into 4-bit binary code. We have replaced the output of DTMF decoder module with a binary code generator to switch on or off the relays. Each relay has two codes, one for switching on and the other for turning off. The table below shows the codes. Firstly, we upload the code file on the PIC, then we set the clock at 8 MHz. After that, we run the simulation and adjust the binary code at 1010 to switch on the relay 1. To turn off the relay 1, we need to enter the code 0001. The relay 2 switch on when the code is 0010. To turn off the relay 2, we need to enter the code 0011. The same way the relay 3 and 4, we need to enter the code in order to switch on or off. Now we can get the whole system circuit gathering the sub-circuits. The reason why we can simulate this global part is because of some missing operating parts in Pro software. Now let's move to the project's implementation. Firstly, PCB designing. On the basis of previous general circuit on Pro software, we have created the film of the circuit, which is shown below. Next, printed circuit board layout. The printed circuit board layout of our system is shown below. The last step is component placing. It involves soldering the electronic components on the circuit board. The 3D circuit forms are shown below. It's evident from this project that an individual controlled home automation system can be cheaply made from low-cost, locally available components and can be used to control multifarious home appliances. This project presented a method to control home appliances using mobile phone and DTMF decoder. DTMF tone is generated by pressing the keypad buttons of the mobile phone. The extensive capabilities of the system are what makes it so interesting. From the convenience of a simple cell phone, a user is able to control and monitor virtually any electrical device in a household. The main advantages of this proposed system are its reliability, low cost, and wide area coverage. Future work for this system can be following adding SMS message to carry controlling commands as alternate way for DTMF tone, upgrading the system to control more than one machine at the same time. Finally, this home automation system can be also implemented over Bluetooth, infrared, and WAP connectivity without much change to the design, and yet still be able to control variety of home appliances. Hence, the system is scalable and flexible.